Momentum is basically a measure of how difficult an object is to stop. So what influences the momentum of something? Well, let's consider a few different scenarios to get to the bottom of it. First of all, what's going to be easier to stop out of a bowling ball and a basketball rolling towards you at the same speed? Well, I think we'd all rather kick the basketball. The bowling ball is going to be much harder to stop because it's got a greater mass. So momentum must depend on mass. Okay, well, what would you rather jump in front of, a snail or a bullet? This time they've both got about the same mass, but the bullet is moving a lot faster. I know I would rather try and stop a speeding snail. So that means the velocity must also influence the momentum. In fact, it turns out that momentum is just a product of these two things. Momentum equals mass times velocity. Now, momentum is always conserved when things collide or break apart or explode, any of those things. The momentum before the event is always the same as the momentum after the event in total. You have to consider all of the objects. Let's just go through an example. I think that's the best way to understand what I mean by that. So let's imagine two cars, car A and car B. Let's say car A has a mass of 1,200 kilograms, car B has a mass of 900 kilograms. Let's say that car B is sitting still, car A is moving towards it at 10 meters per second. They crash into each other and move away as like one big lump. They're sort of stuck together after that. That means the total momentum before is the total momentum after of both cars. So we can use that to work out how quickly both cars are moving after they crash into each other. So let's start off with car A. Car A has a momentum of mass times velocity 1,200 times 10, that's 12,000, plus the momentum of car B. Car B's momentum is mass times velocity 900 times 0, that's going to be 0. So the total momentum before the crash is 12,000 kilogram meters per second. Cool. That means the total momentum after the crash is 12,000 kilogram meters per second. So 12,000 equals the total mass multiplied by the velocity. The total mass, well, both the cars have just stuck together, so it's going to be 1,200 plus 900. That's going to be 2,100. That's quick maths. So 12,000 equals 2,100 multiplied by the velocity. Rearranging that, I get 12,000 divided by 2,100 equals 5.7 meters per second. So that's how we use the idea that momentum is conserved. The momentum before the crash is the same as the momentum after the crash. We use the idea of conservation of momentum to calculate the velocity. Now, this concept of momentum is quite simple. The equation itself is quite simple, but the questions that exams ask you using it can get quite complicated, so make sure you've got a good grip on it.